Okay, people, good morning, 8 a.m. Let's start our class. Uh, First of all, do you have any questions? Okay, silence means you don't. Everything's fine. Huh? Okay, we're gonna work with chapter 10 today. Let me refresh the formulas. So we will work with effective interest rate. 1 plus I, it doesn't matter. I plus 1 or 1 plus I. F is 1 plus I exponent m minus 1. So we remember that f is j1. It's compounded once a year, right? Always. Okay, what else? We have I equals to future value over present value exponent 1 over n minus 1. And this formula pairs with this formula. Any questions? Okay, let's practice. In how many days? Well, why it's here? Hold on, maybe I didn't. Okay. That's okay. Sorry, and I forgot. We'll work with n as well, because chapter 10 that's for time. So that's logarithm future value over present value logarithm 1 plus I, and this formula pairs with this t is n times m. Now looks like that's it. So first question, in how many days will 580 grow to 600 at 5.5 compounded monthly? So guys, you want to try it first, or you want me to just keep going, and as soon as we finish what I prepared, we say goodbye? What do you like? People. Okay, go ahead. 1 minute. Okay, so what I have present value is 580. I have future value is 600. I have J12 is 4.5%. So let's calculate I first. So 0.45 over 12, 0.00375. Okay, and we have n equals logarithm 600 over 580 logarithm 1.00375. So n it is, okay, 600 over 9 057353982. Okay, question. What units for n here? People, what units? If you don't know, say I don't know. I will remind you how to figure it out. Why? No, it's not days. Look at this, what I circled. It's not months, yes. So n, the nature of the n is total number of compounding periods. So whatever compounding period is, n has same unit. So here I have month, right? So it is what? Monthly. So times 12, times 12, that's, oh, y times 12, divided by 12, my bad. What did I put here? Times? It should be divided. And divided by m. Sorry, people. Divided. T is n over m. So I divide by 12. 0.75 4779498. So that is years. And now I do times 365 because I need number of days, right? And I have 275, 49, 45, 169 days. So the answer will be approximately 276 days. Any questions? Do you have the same answer? Okay. So can we continue now? Okay, question number next. If an investment of 800 earned interest 320 at 6% compounded monthly, for how many years was the money invested? Okay, 1 minute to do it. Okay, so what I have present value 800. I have interest amount 320. I have J12 6%. I need answer in years, right? So first of all, I need to find future value. 800 plus 320, what is it? 1120. Now I is 0.005, so n would be logarithm 1120 over 800 logarithm 1.005. Okay, let me make this line shorter. So again, result of my calculations will be in what units? Guys, this 67 and change. Month, yes, very good. Month, right? So in order for me to have years, I would divide by 12. That's 5.621878633 years. So, well, approximately 5.62 years. That is the answer. That is the answer. Questions? Let me know when we're good to go. If you borrow 1,000 on May 1, 2023 at 10 compounded annually, semi-annually, and interest on the loan amounts to $157.63, at what date is the loan due? Okay, guys, take 2 minutes and do it. Okay, guys. So what do we have? To answer this question, we need to know number of days. So present value is 1,000. Date 1 is May 1, 2023. Okay. J2 is 10%. Interest amount is 157.63. So first we find future value 157.63. 157.63. Future value. Now we find I 005. That's it. So n, it is logarithm 1157.63 over 1,000 logarithm 1.05. So let's calculate it. 3,000,088,526. So I can drop this. That is what semi-annuals, right? Semi-annuals. So I have to divide by 2 1.5 what years, right? Or I can think, well, this way. I on this point I don't have to convert it to days. I can use 1.5 years. So if I go from May 1, 2023. So what is 1 year? May 1, 2024. Yes, guys. And half a year, what is it? June, July, August, September, October, November. November 1, 2024. That is the due date. Any questions? Did you have the same answer, or you just guys following me what I do? If you're following me, let me do it and you follow, and we don't spend time when you try to solve it. Okay. Can we continue now? Joanne borrowed 3,000 today with the understanding that she would repay the loan in two payments, 1,600 in 1 year and second payment of 1,700. If interest is 8% compounded quarterly, when would the second payment be made? So you guys do it? Try it? People, would you like to do it on your? Okay, go ahead. So take what? 3 minutes. And who following me, guys, recommending you to actually try and do it on your own. Okay, so this question is for equated date. So loan now 3,000, 1 year first payment, and we don't know when, 1,700. J4 is 8%. Okay. Focal date, guys. When is the focal date? People, for questions of equated date, what date we choose as a focal date? Now, yes, please remember that. Focal date for this kind of questions, always now. So let's create an equation. So 3000 equals to 1600 negative 4 plus 1700 negative n, right? So we calculate whatever we can. $3,000 equals to $1,478.15 plus 1,700, 1.02 negative n. So 1521.85 equals to 17,00102 negative n. At this point, what we say that it looks like present value formula, so it is PV, it is FV. Therefore, we use formula for n. We don't have to use algebra and actually create logarithmic equation and solve it. So logarithm 1700 over 1521.85 logarithm 1.02. Okay, so what is this? $5.59024564.6. And those are what? Quarters, right? Those are quarters. And let's divide it by 4. So approximately 1.4 years. That's when 1700 has to be paid. Well, if we want to be precise, let me see if I have, yes. So the answer is T 1.39, because quite often questions say give answer in number of years and month, right? So what we do, we separate 1 year, right? And then we take 0.39, 7, 5, 6, 1, 4, 1, 1. That's years, and times 12. So minus 1 times 12. And I have 477. 0.7366937. That's month. So we can round up and stop at 5 months here, right? For the practice, for the sake of practice, let's separate 4 months and plus, actually not plus, just 0.770736937 times 30. Well, it will be approximate value because what months they vary, approximately 23 days. So I can say 1 year, 4 months, and 23 days. That's the most accurate answer among those what we calculated here. Okay, questions? Let me know when you're ready to continue. Okay, Joel's Furniture had a financial agreement whereby to pay where payments were required, 14,000 in 8 months and 15,000 in 14 months. Instead of these two payments, a single payment of 29,000 could be made. If money is worth 10% compounded monthly, when would be the single payment have to be made? Okay, guys, take 2 minutes. Do it. Okay, people. So let's create a timeline. So now 8 months I have 14k, and 14 months that's 14. Wow. I have 15k. Okay, somewhere here I have 29,000. Okay, I have G12, 10%. Focal date is here. So everything goes backwards. It means I will use present value formula. So 14,000, 1 point, let's see, what is I? 0083 in period minus, oops, uh, this minus is too low, it has to be exponent, right? So minus 8 plus 15,000, 1.0083 in period minus 14 equals to 29,000, 1.0083 in period minus n. So that is our equation. Please, if you have any questions, please ask. And of course, I would like you to calculate with me. Okay, 68 equals to 29. negative n. So 13,172 plus 13,354.68. That's 26,455.40 equals 29,10083 period negative n. Now, as the same as we did, this guy is present value, this guy is future value. And we have n equals to logarithm 29,000 over 26,455.40 over logarithm 1.0083 in period. Okay. Have 11,066,1183. Well, now I judge what I have. I have months, right? 18, 14. So those are months as well. So I could say 11 months. 11.1 if you wish. Questions, people? Let me know if you have any questions. So have you done your calculations? Can we continue? Okay. Here we have what about interest rates. Would you like to have a 10 minutes break in between, guys? Or we can work today without any break. What would you like? Break. Okay, so let's have 10 minutes break. So be back at 8:43. So break, guys. Okay, guys, break is over. Please say I when you come back. Okay, thank you. So we continue with interest rate, right? Okay, Yinli deposited 800 into a savings account that compounded interest monthly. What nominal annual rate compounded monthly has earned on the investment if the balance was 952.75 in 5 years? Okay, guys, so 1 minute. Do it. Just to refresh, formula is I equals future value over present value, exponent 1 over n minus 1. That is the formula. Okay, so let's see what we have. We have present value equals 800. We have future value equals 952.75. Time is 5 years, right? M is 12, and that's about it, right? What nominal annual rate compounded monthly? So we're looking for J12. Okay, so I is 952.75 over 800. Now 5 years monthly, n is what? 5 times 12 is 60, right? So 1 over 60, that is exponent minus 1. So let's calculate I. 952.75 over 800, exponent 1 over 60 minus 1. I have 0.0002916.592. And I remember that I need to perform one more step, right? What is it? I have to times 12 times m, and what I have 0.034999102, and answer J12 approximately 3.5%. Any questions, guys? Let me know when we're good to continue. Okay. What is the effective annual rate of interest if 450 grows to 750 in 3 years and 5 months compounded monthly? Okay, guys, 1 minute. Please do. Okay. So we need to find compounded monthly interest rate and then convert it to effective rate of interest. Of course, we can go to effective rate right away, right? But let's practice what they meant us to practice. So it is 750 over 450. Now, 3 years, 5 months monthly. So let me see what n is. That is what? 3 times 12 is 36 plus 5, 41. 1 over 41 minus 1. So 750 over 450. Hold on. Let me do it again. So exponent 1 over 41 minus 1. And I have 0, 0, 1, 2, 5, 371. Here I don't have to find j. I need to continue with this formula for effective interest rate. And let me put formula first, so I just remind you. Right, so I need I, and I have it. I just calculated. Right, so exponent m, which is 12, right, monthly, minus 1. So f, it is 0.1612650012, or 16.13%. So, any questions? Any questions, guys? Well, if you want, you can have 16.1265%. That will be probably the most accurate answer. Okay. Give me good to go when you're ready. So an amount of 2,300 earns 500 interest in 3 years, 2 months. What is the effective annual rate of interest compounds monthly? If interest compound monthly. Okay, people, take what, 1 minute, do it. Or 2 minutes, so you don't rush. 2 minutes. And so effective rate again, scenario is the same, right? That is I equals to 2800, which is future value, over 2300, which is present value. And now I have 3 years, 2 months monthly. That is what? 36 plus 2, 38. Right? Let's calculate. So I have 0.00519. At this point, I know it's very tempting to round it. I still recommend keep it as is. And then f is 1.005190008, exponent 12 minus 1. Let's see. 0.064089007, so approximately 6. Well, and again, depends what accuracy we need. I leave it as this. So let me know if you have any questions. Are you ready, guys? Can we continue? Okay. So question number next, what is the nominal rate of interest compounded quarterly if the effective rate of interest on an investment is 5.3%? Okay, 1 minute, guys, please do. Okay. So we're looking for quarterly compounded interest rate G4, right? What do we have? We have effective rate, we have F is 5.3%. Here we will use that technique. I know it is a formula, but this formula is what I don't like this formula, right? So I offer you to do this. 1 plus I exponent 4 equals 1.053, right? So I is 1.053, 1 over 4 minus 1. So I, it is, let's calculate it, That's 0.012994513. And of course, I remember to perform last step, which is times m. In our case is 4. That's the answer. So J4 approximately 5.1978%. And here I analyze my answer. It means the more I compound, the less nominal interest rate I charge. That's what happened. 5.3 I compounded once a year because it is J1, right? Guys, so I started to compound 4 times instead of 1 time. So I reduced nominal interest rate from 5.3 to 5 point roughly 2. Questions? Do you have any questions, people? Okay, let's continue. The Treasurer of National Credit Union proposes changing the method of compounding interest on premium savings account to daily compounding. If the current rate is 6% compounded quarterly, what nominal rate should the Treasurer suggest to the Board of Directors to maintain the same effective rate of interest? Okay, guys, what? 2 minutes, do it. Okay, guys. So what we have? We have J4, 6%. What we're looking for? We're looking for J365. Yes? So let me see. 1.015 exponent 4 equals 1 plus I exponent 365. So I will be 1.015 and 4 over 365 minus 1. That is our equation. So 4 over 365, store 0. 0.000163176, and now I remember to what times 365. I have 0.059559309. Not really big change here, right? So let me double check that. I had 6 compounded quarterly effective, now 365 compute. Yeah, that's the guy. So it is 5.95. Let's put 6%. Something like that. Now, let's talk about this. To maintain same effective rate of interest, it means that those two rates, J4 and J365, they are equivalent. Okay? Questions? So let me know when you're ready to continue. Okay. So Ying invested 5,000 into an account earning 275 interest compounded daily for 2 years. And we have 3 questions. Okay, take 2 minutes, please, and do it. Okay, guys. So what we have? We have present value of 5,000. We have J365 2.75%. We have time 2 years. Balance. Simply find future value. 5,000. And I have, let me see what is NI. So I have 1.000075342 Okay, exponent is 730. So future value it is 5,282.69. That's 1, 2. How much interest? Interest is 282.69. Effective rate of interest, so 3 F is 1.000075342, exponent 365 minus 1. So F is, let's calculate, 0.02788.055. So I can say, let me change color here, that 2.7881%. That is effective rate of interest. Questions? So let me know when we're good to continue. Okay. Surinder borrowed 1,200 and agreed to pay 1,400 in settlement of a debt in 3 years, 3 months. What annual nominal rate compounded quarterly was charged on a debt? Okay, guys, 1 minute, please. Do it. Okay, so let's see. So we have compounded quarterly interest rate. I is 1,400 over 1,200. Exponent is 3 years, 3 months. So 3.25 times 4 is 13 minus 1. So let's see. 0.01192 8326. So let me double check. Yes, and final step is 2 times 4. 0.047713305. So J4 approximately 4.771, something like that. Okay, questions, people? Okay, let's continue. Joseph invested $17.50 into RSP that earned interest at 5% compounded semi-annually for 8 years. So, yeah, take please 2 minutes or three minutes and do it. Okay, let's see. So balance, that's the future value, right? So future value, it is 1750 and 1.025, 16. So 1025 exponent 16 times 1750, $2,597.88. You guys have the same answer? I'll double check better. Yeah, okay, because sometimes calculator gives me some gremlins. Interest. Well, interest is 800 interest, that's I. Interest amount is $847.88. And 3, effective rate of interest. So F is 1.25. Oops, 25. Let me fix that. Okay, now exponent is 2 minus 1. So 0.050625. So 5.0625% compounded annually. That is effective rate of interest. Okay. Sasha promised to pay 3,000 in 212 days, 5,000 in 5 years. Years. No. No. That's, I didn't fix it. That's 2 and 1, 2 years. 2.5 years. 5,000 in 5 years. If she replaces those payments with payment of 4,000 in 4 years and 3 months, and money is worth 10% compounded quarterly, when should she make the second payment of 6,000? Okay, do it. What about, let's say, 3 minutes. Yes. Do you hear me? Test, test. Okay, good. So let me make a picture here first. So what I have now, 2.5 years, 3,000, that's 3. 5 years, I have 5K. Okay, so instead of that, we pay in 4 years, we pay 4,000, and 4 years, 3 months. 4 years, 3 months. And somewhere here, we pay $6,000. Let me see. There I have. So let me do agreement by agreement. Focal date is here. So agreement 1, that is 3,000. And let me see. 0.1 over 4, 1.025. So we have 2.5 times 4 is minus 10, plus 5,000, 1.025. So 225, 5 times 4 is 20, right? So agreement 1, let's calculate. So $2,343.60 plus times 5,000. So $3,051.35. So in total we have $5,394.95. So please confirm my number, guys. Yes, guys. Yes or no? Okay. Let me know when you're ready, because I need to flip a page. Okay, so agreement 2, let me change color for red. Agreement 2 is 4,000, 1.025, and it was 4 years, 3 months. So I compound quarterly, it means 13, right? Quarter, so exponent minus 13 plus 6,000, 1.025, exponent negative n. So A2 is, let's calculate. I have 2901.68 plus 6,000, 1025. It's 2 negative n. Now, at this point, we make equation. So agreement 1, which is 5394.95 equals to 2901.68 plus 6,000, 1.025 negative n. Okay, let me do some calculations, and I go 2493.27 equals to 6,000 times 1.025 exponent negative n. So again, same technique. Let me see. Yeah, I still have some place. That is a present value. That is future value. So n will be logarithm 6,000 divided on $2,493.27 divided on logarithm 1.025. So let's calculate that. Music logarithm divided. So 35.56384988. Those are quarters, right? So let's divide by 4. What do we have? 8.89 years. Let me see. Yeah, well, it's okay. So questions? Let me see. Yeah. It was the last question for today. Let me know when you're done. Done. Okay. So here is your exercise, page 413, chapter 10. Okay, so basically we have 2 classes, which is Wednesday and Monday before the final test. I would like you to have your questions ready Wednesday and for okay. So please, guys, have your questions ready, and we will start preparation for the test. Actually, that's what we do all the time anyways. Okay, if no questions for today, we will say goodbye and see you Wednesday. Okay, guys. Okay, thank you. Bye-bye.